Sir, shall we start, sir?
கேக்குதுங்களா? ஹலோ.
Yes, sir. Audible.
ஓகே
Audible.
ஓகே மேம்.
Start பண்ணலாமா, sir?
ஸ்டார்ட் பண்ணலாம் மேடம்.
Yeah, okay. Okay.
நான் கேமரா ஆஃப் பண்ணிட்டேன் மேடம். நெட் கொஞ்சம் ப்ராப்ளமா இருக்கு.
Okay,
கேமரா ஆஃப்
sir. நீங்க
பண்ணிடுறேன்.
அதுக்கப்புறம் நீங்க ஆன் பண்ணிக்கோங்க. பிரசன்ட்
ஓகே ஓகே மேம். தேங்க் யூ.
சரண்யா.
Yes.
Start.
Good afternoon, everyone. Small cheer and great welcome makes a merry feast. It is a great pleasure to welcome you all to the webinar organized by Institutions Innovation Council along with the Department of Mathematics to discuss on the topic prototype process design and development. If your actions inspires others to dream more, learn more, become more, you are a leader. I welcome one such personality, Mrs. S. Kaunti Ma'am, Head of the Department Mathematics, to share a few words with us.
The most respected guest speaker of the day, Dr. Nandakumar Sundarraju, and respected faculties and my dear students, good afternoon to all. Today, Department of Mathematics CA organizing webinar on process design and development. So in our college, IIC is set up to encourage the creative energy of our student population to work on new ideas and innovation and promote them to create startups and entrepreneurial ventures. First and foremost, I welcome our guest speaker, Dr. Nandakumar Sundarraju, Assistant Professor, Senior Grade in the Department of Electrical and Electronics Engineering, Coimbatore Institute of Technology, Coimbatore. I welcome you, sir. Introduction about our guest. He obtained his PhD degree in Electrical Engineering from Anna University, Chennai in the year of 2020. And he obtained his master's degree in specialization of power electronics and drives from Anna University, Chennai, and bachelor's degree in electrical and electronics engineering in Bardiyar University, Coimbatore. His area of specialization in research are power electronics, optimization techniques, power system control, and electrical drives. He has published several articles in international journals and international conferences. He is an active professional member of ISTE and ISSE. Today, he will be discussing about process design and development. On behalf of Sri Nehru Mahavidyalaya College of Arts and Science and my own behalf, once again I welcome you, sir. And also thanks for accepting our invitation. Next, I welcome our heads of various departments, faculties, and my dear students. Welcome you all. Once again, I welcome you all. Thank you.
Thank you very much, ma'am. Thanks for your offering this opportunity. First of all, I want to thank NSMB College Management and Kaunti ma'am, actually Mathematics Department, and also thank for my friend Lenin Bharti sir, Physics Department. Okay, thank you all. So shall we start, ma'am?
Yes, sir. Saranya?
Thank you.
Yes, ma'am.
Yes, ma'am. Yes, sir. You can start, sir. You can start.
Okay, thank you.
It takes courage to grow up and become who you really are. Now, I would like to invite our chief guest, Dr. Nandakumar Sundarraju, Assistant Professor, Department of Electrical and Electronics Engineering at Coimbatore Institute of Technology. Sir, the session is yours, sir.
Thank you, ma'am. Yes. Ma'am, is it visible now?
Yeah,
Hello?
sir. It is visible and audible. You can.
Okay, thank you.
Proceed,
Thank you. Okay, so just a minute. Okay, and before we start the topic, what is the prototype? Actually, we have different terminologies to explain the prototype. Is one of the Wikipedia definitions. A prototype is an early sample, model, or release of the product built to test a concept or process. So when we go for any kind of prototype, either we go for a software model or physical model or a financial model, wherever we go to release the product, before that we have to make a simple simulation. Okay, so why we need a prototype? So is it need for us? Definitely it is need for us, because prototype helps to analyze the model. So we can simulate the real and future issues, and we can analyze the future events and what are the problems happening in the real model, and we can get the different types of feedback from the customers and users. So according to the feedback, we can improve the model, and also we can update the model. So these are the things that are required to develop any kind of product. Okay, and before that we need to develop this prototype. A prototype may be a physical model, either a physical model, or you can use a software model, or can use a financial model. So we have different types of physical model. That is in simply we can say it's a product-based model, or that is online or offline model. Offline model means the product-based, or online model means computer or program-based models. Okay, so how to create the prototype? Suppose we start the prototype, before we go for the prototype, what are the steps and what are the idea behind to create the prototype? So first we have to connect the proper results. Suppose you are going to design any product, first we have to understand what are the problems and what are the factors around the product, and what kind of user requirement, and what kind of our facilities. So we have to analyze all kind of researchers before we create this model. First we have to connect the proper research. Then we can design a plan, or you can draw a simple plan how to make this prototype, how to reduce the scale on the prototype. And prototype means we have to reduce the scale. There is an idea. And suppose you are in the software model, we have to reduce the number of codings, the number of activities, the number of programming levels in the software model. Either we go for physical model or software model. First, we have to conduct the proper research based on the different factors, and model factors, and customer factors, and user factors. So we have to collect the different factors from the environmental. Then we can make a simple plan. So according to the feedback and according to our facilities, we have some constraints, because we have some constraints, so we can't apply all kind of variables. Suppose we are go for optimization. In optimization says whether we go increase the maximization of the function or minimize the function. According to the increase the function or decrease the function, we have some limitations. So these are some constraints. Also some limitations of the variables. We can't change all the variables. Suppose, for example, suppose you want to increase the speed of the fan, a ceiling fan. So suppose you want to increase the speed of the fan, what will you do? Either we can go for increase the voltage of the motor, but we have some limitation. We can't increase the beyond the standard voltage. We have some 230 voltage standard voltage. We can't increase the standard voltage. Suppose you want to increase the wind level. So what we do? Either we go for increase the speed of the fan, or we can increase the just a minute. So some variables are not practically possible. Okay, some variables are practical, but we will focus only practically possible variables. Practically impossible variables, we can't do this. Okay, and after conducting the proper research, first we have to set the proper variables, and we can set the proper constraints. Based on the constraints and based on our available possible variables, we can develop the plan. So then after making the plan, then we go for directly, we can go to develop the virtual model, or that is a simple virtual or a real-time model, the scale down model. Simply you can say scale down model. So after reducing the scale down, so what will we do next? Next we can go for a testing process. So in the testing process, we have a different functionalities. We have to take out different functionalities, and how the product works in different environmental conditions. Already we have analyzed the environmental conditions, so how the particular product operates in the different functionalities. So we have to analyze all kind of functionalities, and before that we have to make either we go for simulation, or we can go for the hardware. So first we have to address the proper functionalities. Suppose now our windmill product, like ஒரு bicycle நீங்க analyze பண்ணோம் அப்படின்னா, first we have to make a simple product. After that, what is the condition of the road, and what is the condition of the road? We have to make a formulation of the real-time functionalities, road functionality. Then after that, what is the speed of the wind, and what is the... So those are some constraints. Okay, so after that we can go for the testing the prototype with different functionalities. So finally, we have to, once you complete the product, then we have to allow the user or customer to demo our product. Okay, these are the basic steps to create the prototype. So next is the design thinking of prototyping. Okay, in design thinking, we have 5 important steps of design thinking. The first one is empathy. Okay, this empathy is one of the important steps, the primary step. In this step, we have to allow the designer must connect the customers in both physically and emotional ways. So the designer able to learn how customer interact with the environmental factors and personal experiences. For example, for a simple example, நம்ம recent வந்து is Axia 3 is very simple event. So என்ன பண்றாங்க அப்படின்னா, the companies mostly create the market by using the customer ideas, customer beliefs, emotions, so which directly convert to the business model. Very simple. It's one of the simple examples to analyze the empathy. Suppose நீங்க ஒரு மார்க்கெட் டிரைவன் பண்ணணும் அப்படின்னா, not only technical மட்டும் is not support. Okay, so when we go for give the vision market, we have to think about the customer, because user is the ultimate. Okay, either we divide anything we can do with the help of technically, but ultimate user is the customer. So we have to focus on the customer side. So based on the empathy concept, we can divide into 3 categories. There is the observation, enhance, and the reason. Okay. So this analysis phase can be broken into 3 categories. Observe, there is a user behavior. So we have to, designer must watch the user behavior physically. So how the user reacts for the different factors and the environmental factors, how the user react for these issues. Then we have to engage. That means it's a simple intro. You have to make a simple conversation with the user to collect the more emotional information, because the emotional information and physical is more important to analyze the particular character. So, and the third step is you have to watch and listen how the user complete the task for particular domain or particular environment. So we can analyze the psychological study. So these are the important steps to design a problem statement. Okay. So next is the define. So the second stage of the prototyping, and so based on the learning from the emphasis, we can collect, designer may will collect a lot of information. So based on the information, he can define challenges. So what are the challenges here? What's the goal of the define stage here? Here you have to create the meaningful problem statement. That is one of the important role in the define stage. So in the problem statement, they focus on the user requirement. So it's not only for the technical side, and also we have to discuss about the user requirement. That is one of the important role in the design stage. And the problem statement not only help to solve the customer requirements, also helps to designer to create the cost-effective innovation and to create the meaningful problem statement and address the right problem based on the user requirement, have a chance to strengthen a design and create an innovative thinking process for designers. It helps 2 ways. The first one is already discussed. The first one is the customer side. The customer side, we can satisfy the requirement, and the second way, it helps to designer to create the to bring a lot of innovation ideas and new innovation concepts. So this is a general stage. We can get a lot of information from customer side and also designer side. Next, idea. So ideation focus on the generating ideas, concepts, and outcomes. So now the designer can explore a lot of ideas and explore a lot of ideas, not only ideas apart from the innovation concept and outcomes. So these are the factors where we can easily decide the best design solution based on the customer needs. And we have to focus on the customer analysis and the collective idea from the different stakeholders. Stakeholders may be from the team members and end users and team leaders. We have different stakeholders in industry. So here designer collected a lot of idea from the stakeholders and also get the information from the feedback. There is a feedback from the end user. Okay, there is an idea, and also helps the designer to explore the best solution based on their customer feedbacks and customer flexible opinions, and also the useful information from the team members, managers, and different supervisors, engineers. So we have different people in the industry. So we have to collect all the information from the different people and we to make a simple decision. And before finalize the process, a designer able to communicate all the team members in this company. That is one of the advantages for this to making this ideation process. And next one, after that, we have to go for the prototyping. So this is the next stage of the design thinking. In this prototyping, we have to create the process of experimental model to test and validate. There is an idea behind the prototype. And in conventional prototype models, they use a minimum number of variables, because due to some software issues and due to some software limitations, in conventional prototype does not use more number of variables. It uses only limited number of customer feedbacks. And nowadays we have efficient software, the AI system software, so we can collect a lot, the more number of user feedbacks, and you can collect a lot of variables from the various environmental factors. So nowadays AI tools are also very important to analyze the prototyping. So the best prototyping practices, so when we go for design a prototype, we have to go for some practices. So one of the AI tools will collect all the information from the end users and also industrial factor. Okay, so best practices, come to the best practices of to design a prototype. It must be a cost effective and avoid too much of time spending to design a particular product. So when we go for prototyping, it does not consume more time because we have some limited time, because once you go for manufacturing, it will take more time. So before that, we have to use it for only a few hours or few days to make this prototype. So to avoid too much time spending to design a prototype, next, identify the suitable testing and validation method. That is another important practices. When we go for any type of tool, this tool will practice these techniques. After that, the designer prototype must have a consumer feedback. So must have a valuable consumer feedback, because consumer gives a lot of feedbacks, and some feedbacks is not possible, and some feedback is possible. So what are the practical possible feedbacks and what are the non-practical possible feedbacks? We have to categorize the feedback. So designer prototype must have a proper feedbacks. It should cover all the feedback from the users. So these are the best basic steps of the. Next one is the testing. This is the final stage of the design thinking. And in the testing side, designer has to complete all type of testing based on information from different levels. So we have information from supervisor side, we can information from the end user side, we can information from the team pair. So we have different information from the different environmental. So designer has to complete all type of testing, possibility of testing based on the information at different levels. And designer maintain the transparent testing report. So once you conduct the testing, physical testing or software testing, we have to make a proper technical report. So once you conduct the testing, then make a report properly. So technical report is a very important one, and you have to maintain the transparent technical report. You should offer it both online and offline, the printed material and online material also. And designer has to create the best testing environment for the users. So why we have to create the testing environment? Because open environment is one of the important tool for a user because the user to test the prototype in any environment. Then only the user will get some confidence in the physically and emotionally also connected with the business. So these are the very important stage for the design of the design processing the test. Okay. So next you have a prototyping. So what are the different types of strategies in the prototyping? So we have 4 types of strategies follows in the prototyping. The first one is a horizontal prototyping. Second one is a vertical. Then is the task oriented, and fourth one is the scenario based. So these all the categories based on the functionality. So what is the horizontal prototyping? Actually, horizontal prototyping is developing all the units simultaneously at the same time. So, for example, is a software development. When we develop the big software, so we have different units. Already the team manager assigned the different units. So each unit doing the different part of the software. So this is one of the examples. Different people, like team members, develop the code at the same time. Finally, project manager connects all the codes properly with the help of address. So this is one of the example for the horizontal prototyping. And here we have advantages. We can reduce the time making time. But problem here, designer should address the proper units, because address is not proper, so everything will be collapsed. So designer make a proper address for all units properly. That is one of the important limitation. And other than nature of the product, we can go for either horizontal or vertical, depends upon the nature of product. Next one is the vertical prototype. And vertical prototype, we can develop all the units step by step because we can't make a prototype simultaneously. It's not possible in this type. So a very simple example is a building, architectural building, civil building. So this is the function on unit depends upon function of the unit depends upon the function of the other unit. So developing units of prototype is one by one. This is a step-by-step process. So we can't design all the units simultaneously. It's not possible here because the function of the one unit depends upon the function of the previous unit. So here the function will decide the time constraint. Okay, so it takes the more time depends upon the function. So next one is a task-oriented prototype. So task-oriented prototype, it's based on the task. Nature of the task. So developing a prototype based on the nature of task, and each task has one function. So the function will decide the timing. So the time of the process mainly depends upon the function of the each unit, nature of the task. It combines both the horizontal and vertical prototype. Sometimes it depends upon the nature of product. Either we combine the horizontal or vertical, depends upon the nature of product. The function task-oriented prototype, either we can classify the offline prototype or online prototype, like a vehicle design. And so these are some simple examples for task-oriented prototype. Because vehicle design, we have to, sometimes we are going for step-by-step process and sometimes we go for time-based process. So it depends upon the nature of vehicle, we can go for a vehicle, a task that is a horizontal or vertical, depends upon the nature of work. And the next one is a scenario-based prototype. So it is similar to the task-oriented, and there is a difference because this operating function is based on the real-time scenes. Okay, so that is the only difference. Apart from that, concept is similar to the task-oriented. The only difference is operating function. So here, functions based on the real-time scenes. And for this example of the scenario-based prototype is a virus programming, antivirus software. So here, antivirus software operation of the antivirus depends upon the nature of the virus. Okay, suppose vulnerability takes some more time. So vulnerability takes a very minimum time, depends upon the nature of the scenes. Okay, so here the task-oriented function, only task-oriented functions as a limited, so is a fixed interval, because already we have designed intervals, we know the interval level, so we decide the intervals. But here we can't decide the interval because here the interval will be dynamic, so that will depends upon the real-time conditions. So these are the basic prototype strategies. And then next, we move on the rapid prototype. So rapid prototype is actually, what's the rapid prototype? Any idea about the rapid prototype? Okay, manufacturing side to reduce the prototype evolution cycle. So for that, they are moving on the new technology. This is a new kind of concept. There is a rapid prototype. To reduce the time of prototype evolution cycle, the rapid prototype has developed, and the main goal of the rapid prototype is to develop the prototype model in very short duration and an accurate manner. That is one of the important goals for the rapid prototype. And in rapid prototype, normally we are using the 3D printing. 3D printing, we can operate the 3D printing in both online and also offline. Okay, so before that, what are the different types of rapid prototype? In rapid prototype, we can categorize the either online rapid prototype or offline rapid prototype. In offline, we are using the simple paper pencil models, a kind of low probability like paper pencil, the 2D models, and next to the scale the prototype model or move-up models, the 3D models. Then we go for the video prototype model. So we can take videos, and based on the video analysis, we can make a sample prototypes. And we can adjust the corrections, among themselves based on the video analysis. And finally, you have simulation tools. And we have different types of film. For example, CAD is a software which helps for both online and also offline support. And here for our rapid prototype, when we go for 3D printing, we should use a CAD software. Even without any online, we can use a CAD and offline also. That is possible. We can make a program system without using any network. So we can do the programming in both online and offline. When we suppose we go for a cloud environment, so we have to access the online tool. So at the time we can go for the online tool. So it depends upon the nature of work. Either we go for online tool or offline tool. Okay. Then online tool, again, we have a simulation. There is simulation tools are of that in online side, and also virtual reality. So it's one of the latest technology, virtual and augmented reality, to develop the prototyping virtually. ஒரு பெரிய இன்வெஸ்ட்மெண்ட் பண்ணதுக்கு முன்னாடி we can't touch everything. So because ஒரு பெரிய environmentல நீங்க ஆப்ரேட் பண்ணோம் அப்படின்னா it's not easy to connect. So at the time we can go for virtual reality is one of the best tools to analyze everything. So suppose you want to adjust the particular meters, a particular machine and the particular location, we can adjust it. Virtually is possible, but practically it's not possible. Because suppose you want to adjust a particular unit, we have to surround some other units. That is not possible practically. So for that virtual reality helps to this kind of complexity, reduce this kind of complexities, and we can analyze all the units, how to work it, how to adjust the unit particularly without taking other units. So we will study everything in virtually. That helps one of the important tool. Yeah. So next one is 3D printing. So in 3D printing, without 3D printing, you can't image anything in the prototype design. So nowadays mostly 3D printing is there. The 3D printing era, so it dominates everywhere. So not only for making simple toys, it includes like electronics field, medical field, and even 3D printing also used to develop the buildings, and also helps for the food industries, the avionics. So it penetrates everywhere, and the business is also very wide business for the 3D printing. And basically what's the 3D printing is? 3D printing is a process that uses the computer-aided design software to create the objects layer by layer, and is known as additive manufacturing process. It does not require any mold, or does not require any pattern to design the product. It design a product by step-by-step layer. And this process that uses the computer-aided design, this CAD software is mandatory to operate the 3D printer and to create the 3D objects layer by layer. And the operating style of the 3D printer is the opposite to the subtractive manufacturing. Subtractive manufacturing means you are going to removing the metals or plastic materials, and finally we'll find the proper model or product. But here is just opposite to the subtractive manufacturing. And in digital file, we have to create the digital with the help of CAD software. After the digital file is transferred to the microcontroller and control this motor. Okay, there's an idea behind the 3D printer. And 3D printer uses different types of operating materials like ABS, polyamide, polycarbonate, polyethylene. We have different types of materials also there. Okay, so next one is what are the different types of 3D printers? So we have fundamentally we have 3 printers like SLA printers, LSS printers, and DIP printers. And SLA printers equipped with the laser that forms the liquid resin into the plastic, and the next one is a selective laser sintering or SLS printers. It has a laser that sinters particles of polymer powder into the solid structure. The next one is a fused deposit modeling. Same printers is a widely used in the industries and small scale industries and large scale industries. And these printers release the thermoplastic filaments that are the melter through a hot nozzle to form an object layer by layer. These are commonly used in all kind of areas as FDM printers. And one more information there, 3D printers is not used for the mass manufacturing. It's used only for the prototype manufacturing. It's not used for the mass manufacturing. When we go for mass manufacturing, we go for some other technique, molding technique we have. And for prototype only, we can go for this type of 3D printing. There's a limitation of the 3D printer. And this is a simple block diagram of the 3D printer, how 3D printer works based on our commands. So already we have CAD software, the computer-aided design software, CAD software. So we create the 3D modeling in the software, and next the 3D file, the digital file, already used to the 3D object, then it converts into the G code. Okay, then it's a computer code. This with the help of compiler, and this code is directly transferred to the microcontroller, because the machine knows only the zeros and ones, does not understand the high level language. So we have to convert into the zeros and one with the help of compiler. So the image convert into G code, then the G code convert into the binary bits and sent to the microcontroller through the USB. So now this code will directly control the motors. So we have to control the motors in all directions, like all 3 axes, not only for, suppose we are using 3D, so we have to control 3-dimensionally, the x-axis, y-axis, and also z-axis, with different speed and different axes. That is mandatory for controlling the motor, and also adjust the speed of the material injection, that is another important box. So the microcontroller gives the two commands. The one command for the motor driver to adjust the motor access and also speed, and second control is to send the control for material injection. So we have to adjust the material injection where we give the high density of material, where we need a low density of material. So that will decide by the control unit. Okay, so the control unit we have to use the separate signal for the control switches to adjust the movement of the material injection. So the microcontroller will do two things. The one thing is send the information to driver motor. Another thing is send the information to the control unit for the printing material. And these informations are directly sent to the computer with the help of and nowadays we have a cloud machine, so we can access the information directly through the mobile phone with the help of protocols, communication protocols. Yeah. And what are the different types of software in the 3D printing? And these are some basic softwares used in the 3D. Comes under the computer design. There's a Control 2.0 and Tinkercad, Blender open source, UV. So mostly we prefer the open source. Why we go for open source? Because it does not require any license. So we can easily use in any machines like Linux-based machines. So we can operate the software directly to the machine. So it does not require any license issue. Okay, that is one of the idea for open source software. These are some basic softwares, and apart from some dedicated software there, dedicated softwares also there are mostly used in the industrial side, but these are some commonly used software for 3D printing. That is a Control 2.0, Tinkercad, Blender, UV tools, Simplify 3D, and Simplify 3D, Tinkercad is mostly widely used 3D printing software. Next, what are the advantages and front of the 3D printing? When we go for 3D printing, you have some limitations and also advantages. So when we're talking about advantages, it's more affordable. It's mostly affordable, easy to use. So it does not require any skilled person. So if you know the simple file transfer technique, you can operate the 3D printing machine, and also more fast. So you can design a prototype of a product within an hour. The very fastest one. And able to operate with the different plastic materials. So we can diffuse the different plastic materials, depends upon our requirement. So you're able to operate all kind of different plastic materials. And the problem is we can't go for bulk production. That is one of the limitations, because when we go for bulk production, 3D printing is not suitable. So at the time we can go for a injection molding. That's good for bulk production. And before we go to the injection molding, we need some prototype. So at the time we can use 3D printing. Once you decide the prototype, you analyze the prototype, then we go for injection molding. So you after analysis, what we do, we have to calculate all the practical parameters. Analyze parameters, then we go for bulk production. And it requires a post-processing data, because once you complete the 3D printing, you need some post-processing detail. And finally, it does not require any high strength. When we compare with the injection molding, it does not give high strength, because you are using a material with light-weighted and light strength materials. Mostly we are using the materials in the 3D printing with light weight, and our strength is with limited strength. So you can't expect the high strength from the material. There's some limitations. And next is a virtual reality. Is another type of rapid technique. Virtual reality is a powerful tool. So it's a powerful tool for design and immersive virtual models. And it is a computer-generated environment with the scenes and the objectives that appears real and making a user feel work with the particular environment. So virtually create some practical environment. And the process of implementing VR technology to create the digital mockups of the product and the concept transformed into the 3D interactive simulation. So the user will feel the 3D interactive simulation easy to control the computers with the help of adjusting the sensors. So everything is possible, but it won't be in real. So it also always all the operations virtually only. real time. This is a block diagram of the virtual reality. Okay, actually this is a closed loop technique. In closed loop means we have a feedback. So feedback is the we call as a closed loop system. A closed loop means we can do this automatically. So without closed loop, open loop we can make an automation. So once you have feedback, you can make an automation. This is a closed loop technique. And here host computer will control everything. So based on the feedback from the hand tracker, the computer will adjust the scenes of the. So initially computer it can create a scene and send the display machine. So now what we'll do here, the human eye understand the virtual objects and adjust the objects level virtually. So now what the hand tracker will tracks the angle of the movement and send back to the computer. So now the computer again update the scene and send to the display mode. This is a closed loop method. Suppose the particular object is in place A. Suppose you want to move the place B, so it will help. So now the hand tracker will adjust the position from A to B. Now there is some angle shift. So this angle shift will decide will sense by the gesture sensing. After that, it will directly send to the computer. So now computer will identify the change of angle. Based on the angle adjustment, it will create the scenes. So this is the idea behind the virtual reality. So every time it update the scenes and update the scenes based on the adjustment of the angle, adjustment of the position in the lab. Yeah. So what are the different types of virtual reality softwares? We have some standard softwares. This Amazon offers the Sumerian product and Google VR and Unreal Engine 4. So Blender. So Blender is a widely used virtual reality softwares and 3D Max. And mostly virtual reality is mostly widely used in the not only design and prototyping and give this training, provide the training and making a hands-on experience of the particular product. So we can do a lot of applications in the virtual reality. So one of the merits is virtual reality helps to exploring the places without affecting the real one, and it creates a realistic world and help in providing the trainings and create the prototype modeling, and mostly we can go for the training without affecting the cost-effective training. It's very simple. It's a cost-effective training and does not have any risk because we are not going to touch a machine directly. So we have only low risk. So we have another problem is once you realize the virtual reality, we have a problem addiction. So once you come to the monitoring, so the virtual reality addiction is a very important issue. Then the impact of the human body. So every time the human body requires the sensing power from the computer, then psychological damage, and another important problem to create the technology is not easy. So like 3D printing is not easy in virtual reality technology. It's quite complex because in 3D technology we have some simple image files and send directly to the machine and we can operate the machine. But here we can't do this because we need a skilled person or skilled engineer required to operate or create this virtual reality environment. So these are some practical issues in the virtual reality. And apart from that, to making the prototype and make a training and give the hands-on training, so this is a very good tool. And here Unity is one of the good tools. And nowadays the Unity used to develop the game environmental platform for the virtual reality environment. And virtual reality also, virtual and augmented reality also very good future in the educational field and also designing a prototype. Okay, thank you. Any queries regarding the prototype design development? Just to understand the design development of the prototype.
Yes, sir.
Not discussed in much detail because you have from different environments. So you see, mechanical people or other electrical people may understand some kind of.
Yes, but it is very useful to the students, sir. Students, okay. If you have any queries, sir, if you interact with the sir, you can ask. Yes, students. no queries.
Okay, if you have any queries, let me know. I will send my email ID. Actually, we have a different types of technologies in 3D printing and virtual reality. I address the only basic things, and if you go in depth, we need a more technical description. That is not easy to understand right now because you people from different environments. That is one of the problem. I just address the basic only. And beyond that, we have to focus on the financial model. So once you release the prototype, so where we go to update the where we go to reach the product. So come to end user, the customers. The customer is the ultimate. So we have to get the feedback, proper feedback from the customers. Then only we can go for the prototype. So without getting the feedback from customers, it's a failure model. Even we have a very good technology, very good software, we can't reach the end user. So first we have to get the proper feedback from the end user, then we go for the prototyping. That is a proper way of the business model. And every time we have to follow the feedback.
Yes, my students, if you have any queries, can interact with sir. The basic ideas they know about it, no sir. What is the prototype types and everything. Based on this, they can create in some idea. I think it is very useful to them. Yes, ma Saranya.
Thank you, sir, for your precious words.
Now I would like to call Saranya from 3rd BS Maths to deliver the vote of thanks.
Good afternoon to all. It's a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to Almighty God for making today's occasion as a grand success. First and foremost, I thank our management for a great support to make this event happen. Next, I express the sincere thanks to our principal, Dr. D. Subramani sir, for his contribution in all our support. And also, I express my heartfelt thanks to our chief guest, Dr. Nandakumar Sundararaju, Assistant Professor, Department of Electrical and Electronics Engineering, Coimbatore Institute of Technology, who, despite his busy schedule to grace the occasion, for making members guided us, but least, I thank all my dear friends for your cooperation this evening. Thank you, everyone.
Thank you.
Thank you, sir. I think it is very helpful to our students. Based on this idea, they can create some new idea now, sir. This is what an IAC is creating.
Okay, actually I had an idea about to show the real-time demo, but it's not possible right because in home, because in college, I will show the real-time demo.
Once again, maybe
I had an idea. Okay, ma'am.
Definitely. You'll come and
Actually, we have designed a simple kind of windmills also there. So I already have an idea, but due to some limitations, I could not able to show it right now.
Thank you, sir. Thanks
Thank
a
you.
lot.
Thank you.
You are spending your valuable time with us. Thank you. Thanks a lot.